Scenario: a ball M1 moves with velocity v1I on a frictionless horizontal track and collides elastically with another ball with a larger mass M2 that is initially at rest v2I equals to 0. That's the before collision, then that's the after collision picture. Question: how does the speed of the two balls system center of mass change, if at all, during the collision? The answer would be, well, it does not change because in a elastic collision, both momentum and kinetic energy are conserved. There are no net external force acting on the system. The total momentum of the system remains constant in time. The only thing that gets transferred is the velocity. What it means by no net external force acting on the system is there is no force of friction, no force of drag, no external forces that is going into the system that is changing the energy of it. So this system is technically closed. Scenario B. Same scenario as scenario A, but this time the two balls sticks together after the collision. Well, here it still doesn't matter. It does not change because in this scenario we call it a perfectly inelastic collision. Momentum is conserved here. However, kinetic energy is not. The two objects sticking together after the collision moves with one final velocity, which is the same. However, energy is lost due to them sticking together. Well, this leads us up to the last question. Which scenario, scenario A or scenario B, will the final velocity be greater? Well, the answer would be scenario A because that final velocity was transferred from the M1 to the M2. In scenario B, that momentum is shared between the two masses. Because the mass is bigger, the velocity decreases. That is the reason why in scenario B, the velocity is less.